Hi, everyone. I'm Zhaozhou Li from the Hebrew University of Jerusalem. Great pleasure to share our recent thoughts on the formation of early galaxies. Here we argue that the star formation efficiency is high in high redshift massive galaxies because of the feedback-free starbursts. A natural expectation for high density and low metallicity gas in that epoch. When the gas density is high, we expect is so high so that the free fall time of the gas clump is shorter than 1 million years. Then the stars can form efficiently before the activation of supernova or strong winds. Also, to form stars efficiently, you have the gas clump has to cool fast enough and be self-shielded from the radiation and supernova winds from earlier generations of stars. All these are satisfied when the gas density is high enough. Such conditions are expected in massive halos at high redshift above a certain threshold. In such halos, the cold gas flow encounters the stellar wind, the supernova wind formed in earlier generation, and form a shock. The gas density is boosted in the shock and then can be fragmented into gas clumps with high density. Because of the high density, the stars form very efficient in those clumps. And similarly, this can apply for atomic instability in a discus scenario. And we expect these galaxies have a very bursty star formation history, with bursts followed by a quiescent period due to the feedback, and until the gas accumulation can set on another generation of starbursts. Also, we expect these galaxies are clumpy. It's a compact assembly of 10,000 state clusters within very small radii, and this can be the progenitors of globular clusters and the birthplace of black hole seeds. Avishai and Juba will talk about this more. Then we have the predictions for the stellar mass function. As shown here, we see the prediction with a feedback-free starburst scenario matches observation well and higher than the standard model's prediction. Also, we have the prediction for the luminosity function and show a good consistency with observation. And we have the predictions for the galaxy size, the gas fraction, attenuation, and the metallicity. All these are available in digital tables, or you can come to me. And in the last minute, I'd like to advise that our recent progress that we are trying to incorporate the feedback-free starburst into the Santa Cruz semi-analytic models and on the graft simulations by Aaron. And this is our preliminary results, and we show that with FFB we do have a higher stellar mass functions than the fiduciary model. Okay, I will stop here. Thank you.
All right. Thank you very much, Aaron and Zhaozhou. And again, feel free to come talk to them at the breaks if you have questions or put questions in the Slack. And so now we have our coffee break.